So we have our to-do list for that particular iteration, which is, again, analysis, development, test, and integrate, very much like a waterfall process. So where do you do the testing? So if you put it into integration and you try and do a pen test, that's going to hold up the whole thing. Or you could do it in parallel, but by the time you get the results, you're probably going to be on the next build, by which time it's potentially out of date. So that doesn't happen. If you start to do code analysis at the development layer, okay, again, you'll get a big report at the end, but you've got to then manually verify all of those vulnerabilities. So what we suggest is to do at least a test on every integration. So for every build, every piece of software that your project outputs, do a test at that point. Then, once you get to the public presentation, well, you may have an insecure application at that point. You know what the problem is, you know where the problem is, and you're told how to fix it. But then let's focus on doing that in the next sprint. So we test again. We can bring that into the testing phase so that for every test, so not for every release, but for every build that we do, every test build or release to the next environment, maybe UAT, we can test for security vulnerabilities. And make sure that the developers know about these problems. So to make sure that they have that report, we can then make sure that we have secure software. So, done the right way, then we can make sure that every build, every release is developed quickly. So that means using some new type of technology, which in fact is runtime binary analysis. It's a new way to do application security. There's a waterfall model. I don't think I'll have time to talk about that. So what I wanted to show you is how that can look in a real product. So if you look at this one particularly, we've got the screens from the application, and they're coded according to the severity of the vulnerability that's inside of those. So the worst is at the top. You can see that this branch search is a bank online, actually, this application. So if we take a look at what's happening inside the branch search, to be clear, at the top paragraph makes it clear for all stakeholders, project managers, not just security people, as to what the problem is. So a malicious user who's not a valid user in the system, doesn't have authentication credentials, username, password, can steal information that resides in the application's database. Oh, that sounds bad. So all of a sudden we elevate the issue from being a technical problem, SQL injection, well, so what, I don't understand what that is, to more of a business problem. Then, to make it really clear, what I'd recommend is to have a video. So what we'll do is we'll go through normal user access. So the user goes into the branch locator, puts in a branch code of 100, and the application responds with the results. Now, if at the same time you're doing binary analysis, runtime binary analysis, we can then see these strings go all the way through to the database. So we can categorically say this is or this is not happening, or this is not exploitable, because we're not analyzing the behavior at the front end of the application. Okay, we're showing it here, but we're analyzing the behavior of the mechanisms of the application. So if we look at the runtime process and the code flow, then we can start to understand how it's working. And then finally, we can make a real exploit. So we're on the branch locator. A malicious attacker can put in a string, and then all of a sudden we have the database displayed on the branch locator screen. So what can we do about it? If I can move to the next slide. Yeah. Well, at that point, if you're doing a runtime code analysis, you can then say, well, sorry. You can then say, well, actually, the vulnerability is in this DLL. And it's in this function inside of this DLL. And because we're doing runtime analysis, we don't have the real source code, but you can reverse engineer the source code back up to pseudo source, so you can actually get the source. And in fact, you can discover vulnerabilities in third-party applications, as we do. And in this case, we can see, well, is a vulnerable source. That's the point at the end of the function where our string leaves the application server layer and goes into the database and is therefore executed. And finally, recommended remediation. This is kind of not so difficult to do. It's textbook information, but relevant and contextual so that development can very, very quickly say, okay, I've seen where the problem is, I know what to do to fix it, and then potentially on the next iteration can code out that vulnerability. So in this case, we're saying avoid dynamic creation of SQL queries and use parameterized queries. Here's an example. You can make it contextual. In this case, it's C#.NET. It could be Java, it could be PHP, anything. So in summary, application securities are bugs, basically, and it should be treated as a quality issue. If you look at the OWASP testing guide, they say you cannot build a secure application without performing security testing on it. So bugs are everywhere, and by extension, security bugs are everywhere. If you look at every single web application that's released, there was a report last year I saw where it was a software as a service scanning company had said that 99% of web applications that they had tested had one or more security vulnerabilities. So there may be some false positives in there, but it goes to show that there are a lot of issues. And if you talk to any developer and say, can you, hand on heart, say you've released a bug-free software, 100% are going to say, well, no, there's going to be some bugs in there. And in fact, that's what you see. If you do any kind of testing on any kind of release, you will always find bugs. And by extension, you're going to find security bugs. So attackers are going for the application and data layer. That's really where the quick win is. If you're going for an attack, even if it's a DDoS, an advanced DDoS isn't just an avalanche of load onto a particular port. It's more like using high intensity functionality in the application. So you could combine a SQL injection where you're doing, you initiate some kind of recursive function on the database and bring the database down. Or the slow loris function where you make a request, but you slowly drip in the request byte by byte into the web server. So the final thing I would say is use the skills you already have in the team. QA and development, generally, it's amazing. I did a talk like this, Agile Application Security, at the Test Management Forum in London. There was 100 people at that event. 5 came to see the talk. Nobody really sees it as their problem. Apart from, well, where does it fall? It's a quality issue, but it's really ultimately the CIO that's going to, his neck's on the line, really, if there's a information breach which is coming through the application. So why not use QA and development to build secure software? And with the right tools, they can go a long way. And that's it. Thank you very much. If you've got any questions, we've got 5 minutes. Otherwise, if you want to see more about this kind of technology, we're at L51, just near Crush and Dash, over on the left, looking from the back. Any questions? I think she's just coming with a microphone there.
Who do you actually see doing the application security testing that you were talking about? Because you were saying, well, you know, you can't get pen testers done in every sprint, whereas those sorts of skills are not normally available within like a system testing team. They'll be testing that the application does what it's meant to, not what it doesn't do what it's not supposed to. So who is actually doing that testing? Who's
doing it? Yeah, well, maybe it wasn't. Maybe I didn't make it clear. I put this together a few days ago. It's automatic. So if you launch this particular tool through a command line integration, it might be part of your build server, have the test run through the night, and then you get a result back which is automatically pushed into maybe Jira or TFS or whatever your bug tracker you're using. The developer comes in the morning with bugs in front of him, security bugs, him or her, and also where it is in the code, and also some tips on how to fix it. So ultimately, the sort of nirvana is to have it automatically running. But another way is just to click test and have the security person could do that. Ideally, I would say the QA person needs to do that. You probably don't want development doing that. I've seen this before where development have control over this, where there's not really been a security department, but they thought, well, we should do something about secure software. And the temptation is to say, oh, well, that's not really a bug. Even though we've proved without doubt that it is a bug and where to fix it, they still do have work to do. They've still got to create the software. There's still a little bit more work to do to code out these vulnerabilities. And when you're under pressures for performance and functionality, I guess if you don't have a security team to push you, then I can see how that would be ignored. So I would say QA, maybe security, but QA or automatic is probably the place it belongs. Any more questions? Okay, thank you very much.